Our focus at the Neurotech RAS challenge was on two critical aspects of sleep health. The CDC emphasizes sufficient sleep for well-being, yet current EEG needs better sleep tracking. Firstly, our US Census analysis uncovered disparities. In Houston example, neighborhoods differ in sleep duration, some less than 7 hours. Our correlation analysis revealed a positive link between wealthier neighborhoods and longer sleep. Is this an urban planning issue or political power issue? This can be future potential research.
Application of EEGs, we looked at automating with machine learning, and I mainly focused on pre-processing of our data, which notably improved our classification accuracy. I started with our 3D array for each patient study, which is a size of the number of epochs, amount of channels, and 3,000 samples, and we cut it down to channels 0 and 1, which only has the EEG waves, because the research shows we can extract significant amounts of information from the frequency component of the EEG readings, and artifacts of interest include alpha, beta, delta, etc. waves. So to measure the contribution that each wave makes, we calculated the power spectral density for each epoch and did a discrete sum over each wave's respective frequency band and assigned these power values in a vector that goes alpha, beta, delta, etc. and concatenate these vectors across all epochs into a power matrix.
Model to actually perform the classification on the vectors for each different epoch. So the way our first step in this is to normalize all of the vectors to make sure that all features are represented accordingly. Then we feed them all to train our model. Then we use the model for prediction by feeding in vectors and asking it to predict the class to which those vectors belong. After that is done, we do some post-processing to remove intermediate blips or irregularities that we noticed were showing up in the data.
Using PowerNap is intuitive. Users are greeted with basic information about our mission and project. Here, an interactive map suite allows users to view sleep data pertaining to various locations across the US. Below our details are details about processing and analysis, including a block diagram of our data path and samples of spectra used in our modeling process. Users can also upload their own EEG data to be analyzed into a hypnogram. Clicking the Select File button allows the user to select a NumPy file from their computer. Once uploaded, they can choose a model to make their hypnogram after. Users can select from XGBoost, a deep neural network, or convolution neural network. Once selected, hitting the Run button will generate a hypnogram based off of the data. The hypnogram is dynamic. Users can either zoom in, focus on specific parts of the hypnogram, or save a screenshot as an output.